All right, let's dive right in. Today, we're talking about the secret engine that powers pretty much everything in the modern world. It's that tiny, incredibly powerful brain inside your phone, your computer, even your car. Let's get into it. I mean, seriously, stop and think about it for a second. The device you're watching this on right now, it has a brain. It's performing billions of calculations every single second just to make this happen. So what exactly is that brain? And how in the world did it get so powerful?
Well, to find the answer, we're going straight to the source. Our guide for this journey is this textbook, which is going to help us unpack what is probably one of the single most important inventions in all of human history. So, what do we call this miraculous little device? Its official name is the microprocessor. But honestly, there's a much better way to think about it, and it's simply this: a computer on a chip.
Okay, so here's the textbook definition. A microprocessor is an integrated circuit. Now that sounds super technical, right? But all it really means is that we took all the core parts of a computer's brain, its central processing unit, or CPU, and figured out how to shrink them all down and pack them onto one single tiny chip of silicon. This is the part that does the actual thinking, turning all that computer code into action.
To really appreciate just how amazing this little chip is, you have to understand where computing started. And trust me, it wasn't small. We're talking about a journey that goes from the size of a giant room all the way down to the tip of your finger.
I mean, just look at this thing. This is the ENIAC, one of the first computers from the 1940s. It was built with over 17,000 big, clunky glass vacuum tubes. They were huge, they got incredibly hot, and they were constantly burning out. This machine filled an entire room, and get this, it had less computing power than the smartwatch on your wrist today. It's wild.
So how on earth did we get from room-sized monsters to something we can hold in our hands? It happened in a few key leaps, and it happened fast. First, these tiny little things called transistors replaced those giant vacuum tubes, a huge step forward. Then, the integrated circuit came along, which let us pack a whole bunch of those transistors onto a single chip. But the real game changer, the moment everything shifted, was in 1971. That's when Intel introduced the 404, the world's very first microprocessor, the entire brain of a computer, finally on one single piece of silicon.
So, what exactly did they manage to squeeze onto that chip? What's the whole shebang? Come on, let's pop the hood and take a look at the core components of this silicon brain.
Now, this diagram shows the basic blueprint for any computer ever made. You've got your inputs, like a keyboard, and your outputs, like a screen. But the real magic happens right in the middle, with three key players: the CPU, the memory, and the pathways that connect them. The absolute genius of the microprocessor was integrating all of this into one single central hub.
At the very heart of it all is the CPU, the true brain of the operation. And it really has two main jobs. First, you've got the arithmetic logic unit, or ALU. You can just think of that as the system's lightning-fast calculator. It handles all the math. Then you have the control unit, which acts like a traffic cop, telling all the different pieces of data exactly where to go and when to go there. It keeps everything running smoothly.
Of course, a brain is no good without memory. Think of RAM as the computer's short-term memory. It's kind of like a messy workbench, holding only the tools and data that the CPU needs right this second. Your long-term storage, on the other hand, is like the giant warehouse in the back, where everything is stored safely until it's needed. So how do all these parts talk to each other? Well, they use something called the bus, and it's basically an information highway system, a whole network of electrical pathways that zips data between the CPU, the memory, and everything else. Without the bus, you just have a bunch of smart components that couldn't communicate with each other at all.
Okay, so now we have the blueprint, but how did these chips go from running a simple calculator to, well, running our entire world? The answer is surprisingly simple. We just got really, really good at cramming more and more and more stuff into the same tiny space.
This progress is measured by something called integration. We started out with small-scale integration, putting fewer than 10 transistors on a chip. Then came medium, then large-scale integration, and that's when the first microprocessors were born. But then came VLSI, very large-scale integration. This is where the explosion happened. We went from thousands of transistors to literally billions on a single chip today. It's just mind-boggling.
To make this explosion in power feel a little more real, let's trace the history of one of the most famous families of processors out there, the Intel one.
This table really says it all. In 1971, the Intel 4004 had just 2,300 transistors. By 1985, that number had jumped to 275,000. But then, look at the year 2000. The Pentium 4 had 43 million transistors. And remember that data bus, the information highway? It went from a little 4-lane road to a massive 64-lane superhighway.
43 million. Just let that sink in for a second. That's how many transistors were on a single Pentium 4 chip. To go from about 2,000 to 43 million in less than 30 years, it's a leap in power that's almost impossible to comprehend.
But you know, it's not just about cramming more stuff in. It's also about how the chip is designed to think. There are basically two main philosophies here, RISC and CISC. Think of RISC, the reduced instruction set, as a sprinter. It does a ton of very simple things, but it does them incredibly fast. CISC, the complex instruction set, is more like a powerlifter. It does fewer things, but each action is a big, powerful operation that accomplishes a lot at once. They're just different strategies for reaching the same goal, unbelievable speed and efficiency.
So we've traced this incredible journey, from computers that filled entire rooms to these tiny chips that hold billions and billions of transistors. And it's a journey that has completely reshaped our world.
When you put it all together, the key takeaway is this. The microprocessor is the unseen architect of our modern age. It's the tech that took computing from the size of a building and put it right in your pocket. It's the engine inside of everything, and this relentless drive to make things smaller, faster, and more powerful, well, it isn't slowing down. It was a complete revolution, born on a tiny piece of silicon.
It's just an incredible story. Humanity figured out how to etch an entire universe of logic onto something smaller than a fingernail. It really makes you wonder, what impossible thing are we going to learn how to do next?